Greetings, this is Eugene the Philosopher, the greatest living philosopher after the unfortunate passing of Quentin Robert de Nameland, who has been the greatest living philosopher before me. Now, it has been a little bit less than a week since the first anniversary of this channel, which was on April the 1st, obviously. So I think it's a good time, and obviously, I mean, no one really celebrated it, if you know what I mean. Well, I did, certainly. If you know what I mean. So it's a good time, I think, to talk about the origins of things, like where things begin and why are we interested in this in the first place. So at first, I think I would give you like 3 examples, and then actually 2 of those examples I've already talked about in other videos, but anyway. And later we'll talk about the more general problems like I'm sorry, coronavirus, that damn thing. So anyway, later we'll talk about more general issues like where it all comes from, like what is the philosophical/psychological basis of these sentiments, etc., etc. So, as I've already said, 2 of those examples I've already mentioned previously, in particular in my videos about onion of aliens, you might look it up on my channel, or logical cosmology, which is the same, it's on my channel. So, let's talk about the origins of the universe. That's the first example. So, obviously, as I've already said in my video about logical cosmology, there are plenty of contradictions in Big Bang hypothesis, etc., Big Bang cosmology, and like, well, just to name a few, it contradicts conservation laws. I mean, Big Bang cosmology does. But at the same time, what I didn't tell you, but what I think is true, although I'm not convinced it is true, yet I still think it is that it actually contradicts relativity principle itself. And this contradiction is kind of not strict, at least if you read relativity principle according to Einstein, but it is a contradiction if you read it as Galileo did, for example. So in Galileo's interpretation of relativity principle, what it basically states is that if you have 2 inertial reference frames moving with respect to each other with some velocity, then being in one of those reference frames, inertial reference frames, I repeat, you cannot determine whether it's you moving with respect to the other guy or the other guy is moving with respect to you, right? So he gives this example of a ship. So if you're on a ship which is sailing on a very calm water, you cannot determine if it's you, if you're moving in the first place, right? If you cannot see the land and water, etc. If you're just sitting underneath the deck, whatever it's called, in the hull, I don't know, in the cargo bay, whatever. So, but if you look at the Big Bang cosmology, what we have there is, for example, cosmic microwave background, right, CMB, which has an anisotropy as we measure it from Earth. So, what does that mean? So, apparently, supposedly, when the Big Bang happened, sometime after that, there was an epoch of recombination where basically atoms were produced. And when atoms are produced, which means that protons catch electrons, those electrons that had previously extra energy, they emitted some photons. So this is the origin of the cosmic microwave background in the first place, this process of recombination, of catching the electrons by protons and forming these primordial atoms or whatever. Okay, let's assume that we have this process. Well, then we have this supposed cosmic microwave background, etc., etc. But what we observe from our neighborhood is that we have an anisotropy of this background, which means that it's not uniform across the sky. At some places it's hotter, so it's a bit more energy from it, and at some places it's colder, so less energy, and it's like this axis from hot to cold, right? So the point I'm trying to make is that there is a chosen special reference frame, right, which contradicts, in my eyes at least, relativity principle, and this chosen special reference frame is the reference frame of the universe itself, of this process of hypothetical recombination that supposedly happened under the Big Bang cosmology. So I think, just by measuring the cosmic microwave background, we can determine whether we are moving or not with respect to the universe. That's what I'm saying. And anyone can do that, basically. Again, if you follow the logic of Big Bang cosmologists, which contradicts the relativity principle directly, in my opinion, at least. Maybe like in some time after that, I would regret those words, but at this point, this is what I think. All right? And yeah, so it contradicts at least Galilean interpretation of relativity. And speaking about Galileo, I was always wondering, like, his name is like Galileo Galilei, and it's like, well, Galilea is like a place in Israel. It's basically Jew land, something like that. So I don't know, maybe we should call, like, Galileo Galilei seems like too long. Maybe we should call Galileo like Jew, Galileo Galilei, or double Jew. That would sound even cooler. It almost sounds like the name of some wrestler, like The Undertaker, The Rock versus the double Jew. It sounds kind of cool, but it's just my opinion, of course. Okay, so people say, well, the universe began with a Big Bang. Obviously, who doubts that? But my question is, like, where's the origin of this statement? Like, where's the origin of the very question, how did the universe begin? Like, why isn't anyone questioning the very fact of the existence of the beginning? And again, I refer to my video about the logical cosmology. So what if there was no beginning in the first place? But so far I'll leave this question kind of hanging in space, or in space-time, if you like. So I'll transition to the second example I wish to talk about, which is the chemical elements. And I've had some discussions about this with the SAM group, the structured atom model. I don't really promote it, but I'm kind of involved in it as a side, listener, I guess. So yeah, well, it's just a filler, really. But so in, again, this sort of Big Bang cosmology, what we have is the idea of this primordial nucleosynthesis. So supposedly we've had this super hot ball of matter, which then expanded and cooled, and then chemical elements came into being, right? So this is primordial nucleosynthesis. And we also have processes, again, in Big Bang cosmology, of fusion and fission of chemical elements, right? And we have like supernovae, which like are super hot, dense stars, which fuse elements and then go supernovae and kind of spread those heavier elements around, right? Something like that. But if the universe is not finite in time, which I think I've proven really consistently in my video, Logical Cosmology, then the abundances of elements in the universe that we observe currently should be stable. Like, if you think about it, roughly speaking, really roughly speaking, if the universe is infinite in age, of course infinite is a bit stronger than not finite, but still, if it's infinite in age, just to give you a rough estimate, then let's say there would be infinite amount of time for the light elements to fuse into heavier elements, and at the same time infinite amount of time for heavier elements to decompose, to fission into lighter elements, right? So the conclusion that we should arrive from that is that the abundances that we observe today are balanced. So the processes of fusion increase in atomic number, let's say, and the processes of fission, decrease of atomic number, are balanced. So this is what follows from the idea of the universe, which is not finite in time, nor, in time, or infinite if you want, like, simpler talk. But here, and I think it's let's say a door to some more sophisticated, or at least alternative thinking. And I'm not sure if anyone has tried that before. Like, I think some things may be discovered here. Like, if you just try to, roughly speaking, write an equation of fission processes equals fusion processes, you might actually discover something, but I don't know really. I mean, I would suggest doing that, let's say. Okay, but here I wish to also express a caveat that there's no such thing as average abundances of elements, even in the universe as a whole, because, and it's really big, because the universe is inhomogeneous, and we know that. We observe that the universe is not just some, like homogeneous soup of matter. No, it's actually highly structurized in all those intergalactic filaments, etc., etc. So, and even in a more local scale, if you look at let's say planets are highly structurized. Like, you have one elements on this layer, other types of elements on that layer, etc., etc. If you look at even the solar wind, like, slow solar wind is completely different. Well, not completely, but noticeably different in elemental composition than, let's say, fast solar wind. And that both of those come from solar photosphere. So it's like, well, what the hell? What the hell is going on? And it's the point actually promoted by Hannes Alfvén, that, yeah, indeed, universe is inhomogeneous, and it's seen on all scales. In terms of inhomogeneous, in terms of elemental composition, that's what I'm saying. So, yeah, it's a big caveat. All right. So, and even on observational side, returning to that cosmological debate, we see contradictions with Big Bang cosmology. I mean, Hubble constant is already determined to be not constant, really, which means that you cannot extrapolate backwards. If you assume that redshift, cosmological redshift, comes from stuff going away from us, which is not proven, but it is assumed under Big Bang cosmology, still you wouldn't be able to fit all the stuff into a single point, right? The stuff would kind of miss, the galaxies would miss. So at the point of t equals 0, so to speak, the 0th moment in time, the universe would be still finite in size. It wouldn't be a singularity, because the galaxies would kind of miss each other, etc. So that's the problem that the Big Bang cosmology is facing right now, that the Hubble constant is not constant. All right, so observationally proven, I mean, and at the same time, we're observing like the stars and galaxies that are too old to fit into Big Bang cosmology, etc., etc. Well, again, if you watch my video, Logical Cosmology, you would know that the Big Bang cosmology is rubbish in the first place, so why should we bother? And returning to the elemental chemical stuff, we have the cosmological lithium problem, you might Google that, and things like that. So it's really not settled science, let's put it that way, like very mildly, right? All right. So under the assumption, which I make, that the universe should be not finite in time, so, well, roughly speaking, infinite, so eternal, again, roughly speaking, the abundances of elements in the universe should be stable, on average, although you cannot really take an average, as I've already said, but, you know, something approximating that, right? So, yeah, because it had infinite time to readjust the elemental composition, basically. That's the point. So we should take into account both the processes of creation and destruction at the same time, both the processes that increase and decrease entropy, so the processes that destroy stuff, the processes that accumulate stuff, basically. And we know for sure that there are such processes acting today, even in our immediate environment. I mean, in astrophysical terms, like stars, including the sun, increase entropy through radiation. Again, I've made this point in, I think, the Onion of Aliens, or maybe somewhere else, that the black body radiation that the stars emit is actually the most disorganized, the most chaotic, so the most entropic type of radiation, right? And also the stars emit stellar winds, which are mostly protons and electrons, which is also the most simple, stable particles in the universe. So it's also kind of increasing the entropy. At the same time, stars demonstrate nuclear fission, which also destroys larger, more complex nuclei and creates simpler, smaller ones. And they also go supernovae, which kind of spread the elements around instead of concentrating them, right? So it also increases entropy. But also, at the same time, stars decrease entropy, like we have the gravitation, which condenses, compresses stuff, so it collects stuff, which decreases entropy, technically speaking. And we have fusion processes in the stars, which creates more complex elements out of simpler elements, which, again, more complexity equals less entropy, etc. And then, even not talking about stars, but let's say interstellar clouds or something like that, we have processes like Markland convection, which is basically a plasma drift in a electric current through an interstellar cloud, let's say, which sorts the elements according to their ionization potential, so that decreases entropy because, well, the elements get focused in some sense according to some principles, generally speaking. And in general, electromagnetic forces in space seem to be decreasing entropy rather than increasing it. Again, in general. So I believe that all of that together brings us to the necessity of reconsidering the second principle of thermodynamics, which basically states that the entropy in a closed system should not decrease. You know, there's this old joke about the first principle of thermodynamics, never talk about the principles of thermodynamics. But anyway, so the second principle, and actually in general, all the laws of the statistical mechanics / thermodynamics, they were derived in like late 19th century, again, by Maxwell, Boltzmann, those kinds of people. And they were considering only thermal motion, so the most chaotic possible type of motion. And plus, they were deriving these laws based on the idea that particles only act, like the forces between particles are only repulsive, right? So particles were just like solid balls that can collide, etc., etc. But we know for a fact from observation that electromagnetic forces actually produce structures spontaneously. So it's not it's very questionable, let's say, that you can jump from the model of an enclosed box, which is like where the very notion of entropy comes from, where the particles repel each other and the walls of the box repel the particles, right? So this is the basic setup of any entropic setup, let's say, any setup that promotes principles of thermodynamics. So it's a very far jump from that setup to the cosmic setup where there are no bounds and particles are free to move everywhere. And plus, again, the electromagnetic environment is completely different. It's not the Earth's magnetic field plus electric field and maybe grounding and whatever, whereas in space there is no ground, you know. That's one of the mottos I wanted to propose to the electric universe and plasma universe folks, but nobody seemed to like it. The motto was, there is no ground in space, meaning that there would always be electric forces. You cannot ground yourself to anything in space, really. But okay, that was a pathetic intermission. Damn that corona. So, my point is that in enclosed box on Earth with the gas, you have one type of behavior of particles, but in vastness of space, in all these interstellar, intergalactic clouds, you have completely different behavior, and we can see that. And this different behavior is, again, forming of structures, this intergalactic web of filaments and interstellar web of filaments and whatnot. And we can see it everywhere, basically, right? So it's a completely different behavior. So the question is our thermodynamics fit to describe that? And my answer would be no, because, well, yeah, it seems like old thermodynamics was cool, like it was applicable for these like combustion engines of like late 19th century, early 20th century, and even today. I mean, it still works. But that's about it. I mean, it's not really applicable to anything else, or at least it seems so. And maybe it would solve actually some problems in like meteorology and blah, blah, blah. So there's a lot of areas of physics which are affected by our thermodynamic concepts which come from late 19th century. And I believe, again, I've expressed this thought many times, that these are three areas where a serious revision is needed. That's logic, thermodynamics, and statistics. And they're all connected, so it's not a big miracle that I kind of mentioned them together. So yeah, thermodynamics needs a serious revision. And let's say, if you look at ergodic hypothesis, which is one of the, how do you say it, like main pillars of thermodynamics, which basically states that, ergodic hypothesis states that the average over an amount of time that an statistical ensemble has or spends is equal to the average over a large amount of same statistical ensembles. So it's like, you know, equating time and in some sense space, but whatever. It's a hypothesis and it cannot be proven, but it's very important for thermodynamics as we know it today. But it's principally like it cannot be proven. It's just a game of thought. It's an idea. It's a way of looking at things rather than the way things are, if you know what I mean. All right. So obviously all those ideas about the heat death, like thermal death of the universe, are rubbish, again, as I've already mentioned in my video about logical cosmology, etc., etc. So the third example I wish to talk about is life. Again, I've already kind of mentioned it in my video about onion of aliens, but here I just wish to repeat is that, following from my definition of life, which is life is a phenomenon which repeats itself in time and multiplies in space. We cannot really talk about the origins of life. So whenever, and obviously, again, returning to the topic of the video, people ask, well, what is the origins of life? Just as I've already, in two examples I've already mentioned, what is the origins of the universe? What is the origins of the chemical elements? Let's say, what is the origins of life? And here we have a serious problem, obviously. Like some people say, well, life originated on Earth. Some people say, well, it didn't. It came from somewhere else, you know, panspermia, etc. But even if it came from somewhere else, the question still remains, how did it originate there, wherever it comes from, etc. So, again, my question would be, did it originate anywhere? And the same is applicable to the chemical elements, and the same is applicable to the universe in general. So, did life begin in the first place? And it's a difficult question, I think, but I'm really curious why no one else, at least no one that I know, asks this question. But it's completely justified, I think. Like, again, as I've stressed in my video on aliens, I'm not sure which part, maybe 2 or 3, from the perspective of life, you really cannot determine its origins. Like, really, it seems, from the point of view of a living being, that life existed forever because, well, life is about repeating in time and multiplying in space. So if there was nothing to repeat, how can it repeat, right? If there was nothing that was alive, how can it reproduce, let's say? How can it sustain itself? Like, nothing can sustain itself, but that's not life, right? I mean, something to that effect. So yeah, it's a difficult question. Although I should make another caveat, perhaps, is that I'm not really convinced that life did not have a beginning. I'm pretty convinced, I mean, that's my philosophical position, that the universe does not have a beginning, but and the chemical elements which are associated with the universe do not have a beginning. They did not begin in some wicked singularity, magical process, whatever. I think they've kind of existed forever. They might be recycled in some isolated parts of the, let's say a star produces a certain type of elements, and interstellar cloud, let's say, destroys this type of elements, and this is like this recycling process. Well, something to that effect, in my view, at least. All right. But that was just an example. I'm not really stating that it's as it is. I'm just kind of, you know, proposing an abstract picture of what's happening. All right. So, but life may actually have a beginning, but I'm not convinced that it has. But anyway, even if my view on life is correct at this point in time, maybe life is some sort of nonlinear process. Again, see my video on nonlinearities in time. So maybe, and it's pretty easy actually to envision that, there was a stage in the development of life when it behaved differently. And we don't know how exactly, because there was like a point of bifurcation, or like sudden transition to another state. Let's put it that way. Since when it started to, as I'm saying, like repeat itself in time and multiply in space, but like linearly, roughly speaking. But before that, there was some other thing going on. So maybe, like if we adopt this type of view, we would actually not be able to determine the origins of life in the first place, because it's separated from our view with this boundary, so to speak, of some weird nonlinear process, after which it became more or less predictable, and like the evolution began, etc., etc. All right. Okay. So what else? Okay, so these are pretty much those 3 examples. So the universe, how did it begin? The question always arises. The, what is it? Chemical elements, again, very connected with the universe, and life, which is also connected to the chemical elements in the universe. But where is that the origins of this very sentiment of where does it all begin? Like, why do we always ask this question? Why are we always tempted to ask this question? And see what I did there? Like, I'm currently questioning the origins of the obsession with origins. So that's like sophism for you. Like, it's 500 IQ post irony, you know, something like that. And I would state that it actually comes from the thing that you've probably heard from me many times, which is this Nietzschean will to power. So basically, to reveal the origins of something, to like know it, like where it comes from, how it behaves, etc., etc., it gives you a lot of power over it, right? So uncovering the behavior of some phenomena or some people or some social processes, etc., it gives you a lot of power, because when you know it and how it behaves and where it comes from, you can control it, or you can at least adapt to it. So you can behave in a more optimal manner in terms of increasing your power. You're not a victim anymore. You're more in a position of being aware / being in control, you know, something like that. So let's say, as an example, and because we are for diversity, etc., I'll give you this example. So let's say you have an alcoholic mother who beats you up every time she drinks, and you see that she's drinking. And what is your response? Like, you already know that, right, that she's gonna beat you up. So your response might be, well, maybe I should go outside, and maybe I should spend the night at my friend's, or something like that, so you wouldn't be beaten up. And that would increase your power. You're now controlling the situation. You can influence the outcome, you know. That's the point. So, yeah, this is basically the idea. And this repetition that, you know, your mother drinks equals she's gonna beat you up. It's this if-then structure, which is all about science. Again, I've already stated many times that science is only about if-then statements, not you should statements. You know, this guillotine of Hume, who said that you cannot derive an ought from is, so you should from if-then, roughly speaking. So yeah, if you are aware of those if-then connections, if you establish them solidly, then you can control the situation, you can control the outcome at least, with your own behavior, and therefore you have a power, at least some power over the situation. You can influence the outcome. So it's will to power, the desire to know, the desire to uncover the origins, because that would help you to figure out the behavior, etc., etc., through all those causal links. So in some sense, when people say, oh, I'm just about pure science, or oh, I'm just about pure philosophy, well, what they're really saying is that I want absolute knowledge, I want absolute power, you know, something like that. Like the most undisputed, the most basic element of knowing, which means power. So yeah, they're talking about that. So really, scientists and philosophers, and philosophers even, they're all about power. At least it seems so. All right. So let's take a look at a more like psychological / maybe cognitive aspect of this situation, like when we're trying to uncover the origins of stuff, etc. one interesting aspect is that when we see something happening, we usually tend to, and again, we usually tend to search for origins of this phenomenon, which means that we look for a reason, you know, for whatever is happening. Like, we try to find some responsible agency, philosophically speaking. So any actor, meaning someone that performs action, not acting, you know, something like that. So, like, look at, for example, the phenomenon of crime. So if somebody, let's say, got robbed or murdered, it's kind of obvious that a person did that. So we try to find this person. And why do we do that? Because we want to control them. We want them not to be this chaotic element that disrupts our society, right? We want to constrain them, perhaps even literally in a cage, right? In a prison cell, or like figuratively, like by fining them, by taking money from them, so that they would know that afterwards, if they do the same thing, they would be fined again. So that would be increased suffering for them, so blah blah blah, so they would probably be less incentivized to repeat that, blah blah blah. So you see the point. So we're trying to establish our power over this yet uncontrolled being, let's say. But in the first place, we're trying to find a responsible agency, this perpetrator, whatever it is, and compare this to weather, let's say, or what is called, I'm not sure if it's, well, this, you know, unstoppable force type of thing. Like, if a tornado destroyed your house, it wasn't really an evil will or something. It's just nature. It just does things without any will in it, so to speak. Even though, well, I'll talk about it a little bit later, perhaps. But you see, the interesting phenomenon is that even weather right now is, like, some people try to find ill will, like the crime in weather, for example, and I believe it's one of the really interesting developments of our current society with this, the whole global warming, climate change agenda, because it inserts the human malice, so to speak, the human will into the natural phenomena. It says, well, the tornado destroyed your house, you see, is because people have driven cars and operated like coal factories or whatever, coal power stations, and that changed weather. So because of that, your house was destroyed by the tornado, not because it was just a natural phenomenon. So there is an ill will in this tornado produced by man, you know, by humankind. So it's a very interesting development. And I believe that this idea of human-created anthropogenic climate change has at least some grain, or maybe actually a large segment in it, of this human pride. Like, we actually want to be responsible because we want to be recognized. We want in some sense, I mean, again, it's only a part of the problem, right? But in this part of the problem, we want to be recognized by, well, whatever, the planet, the universe, whoever. We want to feel important, that we actually impact the planet quite a lot, right? But of course, again, as I've said, it's only one part of the problem. A lot of it also stems from what I've called repentive thinking. Again, see my video on repentive thinking if you want to know more about it. But okay, so in more abstract sense, I would say, if we kind of move a little bit back and look at the larger picture, we might see a basic pattern in our cognition where, let's say, and speaking about the blame and like looking for a perpetrator and responsible agency, I cannot, well, it's, again, hype train, baby, choo-choo. Again, speaking about this coronavirus and stuff, I mean, people are trying to find some agency responsible for that. I mean, all those conspiracy theories arise, like 5G towers, evil Zionist occupation government, evil Chinese, Trump, Russia, Europe, whatever. Like somebody created it, somebody enhanced it, etc., etc. So it's very funny to observe, and like someone has to be blamed for it, you know. And speaking again about coronavirus, it's like a bit of a digression, but well, I mean, it's like, to me, it's very funny to observe people in masks today. Like, as far as I know, although some people claim otherwise, is that those masks actually doing a little bit less than jack shit, right, to prevent the spreading of the virus. But anyway, what I've noticed is that, well, at least in my country, most of the people who wear them are women, and that's very interesting in my opinion. It's a little sociological experiment in vivo, so to speak, where, well, my point is that women are always following fashion trends, right? And I'm really surprised that no one has yet, or at least to my knowledge, come up with some meme like fashion trends of the spring 2020 and, like, you know, face masks and stuff. So yeah, but I wish to tell women that if you're really into it, if you really want to be on the verge of fashion, so to speak, then a little face mask wouldn't do a lot to you. I mean, first of all, a lot of women already wear them, but secondly, like, if you want to really attract a powerful, wealthy male, a strong male, you know, which is fashion is all about, you need to, I mean, women's fashion, although some male fashion also probably, you probably need to be ahead of the curve, so to speak, and wear full, you know, biohazard protection suit, something like that. So step up your game, please. All right. So the basic pattern, I believe, that we're talking about here is that, speaking about the pride and responsibility, etc., is that, well, when I'm lifting my hand, let's say, I am sort of creating artificially, like constructing in some sense, at least in my own perception, the agency that did it, so to speak. So I'm creating myself as, or at least I'm perceiving that there is a reason for a hand to be raised, and this reason is me and my will, you know. So this is the very basic pattern that we observe everywhere. So, and later, and I've talked about this in my video about mythology as cultural basis, I think it was called, and nature of knowledge, another video closely related to that. So later I extrapolate this experience of me, like I'm creating myself in some sense by perceiving the results of my actions, you know. By perceiving that something has changed, I assume that there was some agency that produced this change. So later I feel everything with that same sentiment, like I'm saying, okay, the wind blows, it means there's someone responsible for wind blowing. For example, the spirit of wind or whatever, the god of wind, he kind of, or she, produced this new perception that I've had. So this is the basic idea, and again, I've talked about this in the mythology as cultural basis and nature of knowledge videos, and in nature of knowledge in particular, I've talked about how initially, or at least it seems so, the world was perceived by human beings as filled with all those spirits and demons and gods and whatever. They were literally everywhere, and basically any phenomenon that you perceived was perceived as an act of some will, you know, again, of some subject, of some agency, etc., etc. So I believe that this obsession with origins, as I would tentatively call it, again, see the title of the video, comes from somewhere there. So we want stuff to have a reason, or to have an origin, to have a creator, essentially. And it is our self-importance, it is my pride in some sense, that I am responsible for the hand raising, and it's not just risen by itself. It's me who did that, you know. And this is a pride. It's a feeling of power. Again, I am a power. I am in control of my body, etc., in control of the world consecutively through at least manipulation with my own body, etc. So it is our self-importance that requires that everything should have a beginning, that everything should have a source, a creator, a person responsible, etc., etc. So I would state that we simply don't like the idea that there is no such agency, that there might be no beginning. And again, if you look strictly, if you remember the examples I gave you, there might be no beginning to the universe, to the chemical elements, to life itself, etc., etc. And there may be no us, there may be no me in the first place. So basically, I would state that we're only obsessed with the origins of things because we're obsessed with ourselves. Thank you for watching. The eons are closing.